This video will walk you through how to use the quadratic formula. The quadratic formula is derived from the standard form of a quadratic equation. The a, b, and c in the formula come directly from the a, b, and c in the standard form of a quadratic equation. The outcome of the quadratic formula would simply be the roots or solutions if you were to set the standard form of the equation equal to 0. So the quadratic formula immediately gives you the values of x that would make this true. The nice thing about the quadratic formula is it works on polynomials, quadratics that we can factor by methods studied in class, and that means we would have rational roots, roots that can be written as fractions or integers, and it also works on quadratics that we cannot factor by methods learned in class. That would mean that you would have a quadratic with roots that are irrational numbers, something like the square root of 3, a non-repeating decimal. So this would give us an outcome for rational factorable quadratics as well as quadratics that are not factorable. So let's walk through a few examples to get you familiar and comfortable with the formula. So the formula is presented, and you do need to memorize it, and we'll talk about how we can memorize it in class. I'm going to do the example that's given. So here I'm going to use this example, and you can see that it's an equation that's set equal to 0. So let's first identify a, b, and c in the equation. A is positive 1, b is negative 6, and c is positive 4. Always carry the sign of the number with you when you're identifying a, b, and c. So let's set the formula up. I've got a negative sign built into the formula, and my value of b is negative 6. The plus minus will ensure that we get the two roots. Remember, a quadratic can have at most, it's a degree 2 equation, so the quadratic can have at most 2 solutions, 2 roots. So we'll deal with the plus minus when we get to a certain point throughout the process. So here I have plus or minus the square root, and here I'm going to have b squared. So b is negative 6, and I'm going to square that. So when the value of b is negative, you also need to square the negative sign. So this is going to be minus 4, and I'll put everything that's built into the formula in blue, and then I will bring the pieces that I'm bringing particular to this exact quadratic. I will let those be in red, and then we'll analyze what's happening. All right, so 4 is built into the formula. The value of a is 1, and the value of c is positive 4. And then the denominator is 2 times a, and a is 1. So take a minute and look at what I've done. Everything in blue is coming directly from the formula, and all of the numbers that are written in red are specific to this particular quadratic. And now we need to clean up. So I've got the minus 6, which makes that a positive 6, and then plus or minus. And then underneath the radical, I'm going to have 36. And then I would have negative 4 times positive 1 times positive 4, which is negative 16. And that's going to be divided by 2 times 1, or 2. So carrying on, and this is the value of x. So I can say x equals, and then carrying on, I'm going to have 6 plus or minus the square root of 20 all over 2. And moving on one step further, simplifying radical 20. 20 is 4 times 5. 4 is the perfect square. So this is 6 plus or minus 2 radical 5, and then my denominator is 2. Now, I need to simplify this, and if I have a common factor in the 3 spots that I'm highlighting in red, I can remove that common factor and write the most simplified radical form of this answer. All of the numbers in red share a factor of 2. So if I factor out a 2 from each, this is what remains. X would equal 3 plus or minus radical 5. So my roots or solutions, and I would have irrational, so these are irrational roots, because the square root of 5 cannot be simplified. And you could simply leave your answer like this. For this particular problem, x equals 3 plus or minus the square root of 5. So my two roots would be 3 plus the square root of 5 or 3 minus the square root of 5. And you are welcome to just present your answer with the plus negative written on top of each other. Let's do another example. Once you memorize the formula, it's actually pretty simple to do. So let's do a problem like number 1. And here, A is 1, B is 10, and C is negative 2. So once you memorize the formula, then it's actually just moves pretty fast. So the negative signs built into the formula. I will do this one exactly like I did the last one. And 10, the value of 10 is B. So here I'm going to say plus or minus, and here's my radical symbol. I'm going to square B, and then I'm going to subtract 4 times A times C. So here I have 10 slipping in for B squared minus 4 times A times C. And now C is negative. And then my denominator is going to be 2 times A, and A here is 1. So I'll set it up exactly like I did before. Everything in blue is in the formula. Everything in red is specific to this particular problem. And now I'm going to clean it up. So 10 remains negative. And then plus or minus underneath the radical, I'm going to have 10 squared, which is 100. And then I'm going to have negative 4 times negative 2, which is positive 8. And then all of that over 2. And then I'm going to have negative 10 plus or minus the square root of 108 all over 2. And I will ask you for homework to simplify this, to simplify radical 108 and bring your work to class, and we'll compare the answers. So simplify the square root of 108, and then if you have a GCF in the spots that I will highlight in blue, you can remove that GCF, and we can discuss that further in class. I would like to do an example where you have a quadratic that's actually factorable. I would like for you to see what that looks like. So let's do number 3 on the video. The first thing I need to do is set this equal to 0. And then I identify A, B, and C. A is 1, B is negative 8, and C is negative 20. And then I go into my formula. So I have negative of negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times negative 20. And I'll put that in parentheses to make it a little bit neater. So I'm taking this entire product. 4 times 1 times negative 20, and I divide that by 2 times 1. And to clean this up a little bit, the double negatives will become positive, so that's going to be plus or minus. And then here I'm going to have 64, negative 8 squared, 64 plus 80, 64 plus 80, and all of that will be over 2. So 64 plus 80 gives me 144. So I have 8 plus or minus 144 divided by 2. Now notice in this problem, unlike the other two problems, I have a perfect square under the radical. The square root of 144 is 12. So the way that I would present this answer, and this is x is equal to, so here I would say I have 8 plus or minus 12 divided by 2. And now I would split this into two pieces so that I can get my two distinct rational roots. So here I would have 8 plus 12 over 2, and I'm going to have 8 minus 12 over 2. So these are my two roots. And then to clean that up, 8 plus 12 is 20. If I divide that by 2, I get 10. 8 minus 12 is negative 4. If I divide that by 2, I get negative 2. So my two roots are positive 10 and negative 2. So that means that I could have factored this. This could have been factored as x minus 10 times x plus 2, and then I would have gotten the two roots of positive 10 and negative 2. But I would like for you to see that the quadratic formula does work on quadratics that are factorable. If the quadratic is factorable, then you would have a perfect square underneath the radical in the formula. And I will stop the video here.